Hi friends, myself Vinay Borhade, and welcome back to the continuation of the series about machine learning. In the last installment, we looked about linear regression models, simple linear regression and multivariate linear regression. In these models, we usually assume that the relationship between the outcome and the independent variables that it depends on is linear. That is, the rate of change of the outcome with the dependent variables is constant. But what if the relationship between the outcomes and the independent variables is not constant? Let's say, for example, the radium decays a bit faster initially, and as the time goes on, the decay becomes constant. Yes, so this is a classic example of a non-linear relationship between the decay of the radium element with respect to time. If we try to explain these relationships using linear regression models, they will not accurately capture the relationship. To accurately capture such non-linear relationships, we use non-linear regression models. Let's take another example from the industry where such non-linear regression models would be used. Let's say we are trying to understand the relationship between the salary hikes or the percentage of salary hikes that you would get year over year and the number of years of experience you have gained so far. You would have observed that the amount of hike that happens in the earlier years of your experience would be a bit higher, and gradually the percentage hike would get constant or would decrease as the number of years of experience increase. This again is a non-linear relationship between the salary and the number of years. To explain such a relationship, you would use non-linear regression models. To name a few, we have binomial, polynomial, exponential, logarithmic, Gaussian, and many more such varieties of non-linear regression models. We have one specific case of non-linear regression model where your outcome is a dichotomous categorical variable type. Okay, what does this dichotomous categorical variable mean? Is the outcome can have only two states: yes, no, true, false, approved, not approved, and so on. To take an example, let's say we have a loan department in a bank where they have to decide whether a loan has to be approved or not to the probable customer. In these scenarios, we can use logistic regression, which is a type of non-linear regression model, to understand whether the probability of a person defaulting and hence not approving the loan for that customer is high or less, based on some features like age, whether he is salaried or not, how many dependents that does the person have, and so on. We will look into logistic regression model into bit depth in our next installments to understand how these regression models help us to capture non-linear models within the variables.